Elliptical motion, displacement r is equal to a sine omega t plus pi plus b cos omega t plus qj. So what we have is an object going around in an ellipse. And we've discussed this before. The centre would be at PQ. The length of this axis would be A. The length of this axis would be B, and that's just simply because A is with the I component and B is with the J component. Now, what we're going to do, just like we did in the last lesson, is do a transformation, and S then is A sine omega t I plus B cos omega t j. So S is equal to R take away pi plus qj. So we're just simply moving the motion so that it is now centered at the origin. I know my diagram's not perfect there. Then the velocity, V is equal to A omega cos omega t, don't forget the chain rule, take away B omega sine omega t, and the acceleration, differentiate again, A is equal to negative omega squared sine omega t I, take away B omega squared cos omega t j. So we get that A is equal to negative omega squared s. It's just like the last one. If you look at that, where the acceleration is negative A omega squared sine omega t and negative B omega squared cos omega t, we can take out a negative omega squared, and then we get A sine omega t and B cos omega t, which is S. We also get A dot V is equal to R dot V is equal to 0, but that's not always true the way it was for circular motion. That is true for t is equal to n pi by 2, where n is an integer. So basically it just happens at these points. The period of the motion, t, is equal to 2 pi over omega, and that once again is just because the period of both sine and cosine is 2 pi. And so when omega t is 2 pi, we've gone all the way around.